Welcome back to Database Internals Crashcasts. I'm Sheila, and as always, I'm here with my co-host, Victor. Before we dive into today's topic, I want to remind our listeners that if you're enjoying our podcast, please rate us on your favorite podcast platform. Your support means the world to us.
Absolutely, Sheila. And hello, everyone. We're currently in our Introduction to Databases season, exploring different database models. Today, we're moving on to a fascinating topic within our Database Models chapter, the object-oriented model.
That's right, Victor. And to kick things off, I have a quiz question for our listeners. Here it is. In an object-oriented database, what feature allows a new class to be based on an existing class, inheriting its attributes and methods?
Ooh, that's an intriguing question, Sheila. It really gets to the heart of one of the key features that sets object-oriented databases apart. I think our listeners will need to think carefully about the unique characteristics of object-oriented programming to answer this one. It's not something you'd typically encounter in other database models we've discussed so far.
Exactly, Victor. Now, before we delve deeper, let's clarify some key terms for our listeners. Victor, could you give us a quick definition of what we mean by an object-oriented model in the context of databases?
Certainly, Sheila. The object-oriented database model is an approach to database design that uses object-oriented programming concepts. In this model, data is represented and stored as objects, similar to how objects are used in object-oriented programming languages like Java or C++.
That's helpful, Victor. So it's like bringing the principles of object-oriented programming into the database world. Can you tell us a bit about why this model was developed? What was the historical context?
Great question, Sheila. The object-oriented database model emerged in the 1980s as a response to limitations in the relational model, particularly when dealing with complex data structures and relationships. As software development increasingly adopted object-oriented programming, there was a growing need for databases that could more naturally represent and store object-oriented data without the overhead of mapping between objects and relational tables.
That makes sense. It seems like there was a bit of a mismatch between how programmers were thinking about data in their applications and how databases were storing it. So, what are some of the key concepts in the object-oriented model?
The fundamental concepts of the object-oriented model align closely with object-oriented programming principles. The primary elements are 1. Objects. These are instances of classes that encapsulate both data, attributes, and behavior, methods. 2. Classes. These are templates or blueprints for creating objects. 3. Inheritance. This allows new classes to be based on existing classes, inheriting their attributes and methods. 4. Encapsulation. This principle bundles the data and the methods that operate on that data within a single unit or object. 5. Polymorphism. This allows objects of different classes to respond to the same method call in different ways. These concepts work together to create a flexible and powerful way of modeling complex data and relationships.
Wow, that's quite a list. Let me see if I understand this correctly. So, in an object-oriented database, instead of having tables like in a relational database, we have classes. And instead of rows, we have objects that are instances of these classes. Is that right?
That's a great way to think about it, Sheila. You're on the right track. In an object-oriented database, classes do indeed serve a similar purpose to tables in relational databases, and objects are analogous to rows. However, there's an important distinction. Objects can encapsulate both data and behavior, whereas rows in a relational database are purely data.
I see. So it's like each row in our database is not just a collection of data, but also includes the rules for how to interact with that data. That seems powerful, but I can imagine it might also introduce some complexities. What are some of the challenges or potential pitfalls when using an object-oriented database model?
Excellent observation, Sheila. You're right that while the object-oriented model offers powerful capabilities, it also comes with its own set of challenges. Some common pitfalls include 1. Performance issues. Complex object structures and inheritance hierarchies can sometimes lead to slower query performance compared to well-optimized relational databases. 2. Lack of standardization. Unlike SQL for relational databases, there's no universally accepted query language for object-oriented databases, which can lead to vendor lock-in. 3. Schema evolution. While object-oriented databases can handle complex data structures well, changing the schema, that is, the class definitions, can be more challenging than in relational databases. 4. Limited tool support. There are fewer tools available for data analysis, reporting, and administration compared to relational databases. 5. Steep learning curve. Developers and database administrators need to understand object-oriented concepts, which can be more complex than the tabular model of relational databases.
Those are significant considerations. It sounds like choosing between an object-oriented and a relational database model isn't always straightforward. Are there particular types of applications or scenarios where an object-oriented database might be the better choice?
Absolutely, Sheila. Object-oriented databases tend to shine in scenarios involving complex data structures and relationships. They're often well suited for 1. Computer-aided design, CAD, and computer-aided manufacturing, CAM systems, where you need to represent complex hierarchies of parts and assemblies. 2. Multimedia applications that deal with audio, video, and images, where you might want to encapsulate media-specific operations with the data itself. 3. Scientific and medical applications that work with complex data models, like genomic databases or geological information systems. 4. Telecommunication systems that need to model complex network structures. In these cases, the ability to directly represent and manipulate complex objects can lead to more intuitive data models and potentially better performance for certain types of operations.
That's fascinating, Victor. It seems like object-oriented databases found their niche in specialized applications. Can you give us an example of a real-world object-oriented database system and how it's used?
Certainly. One well-known example is Object Store, which has been used in various industries. For instance, it was used by the CERN Particle Physics Laboratory to store and analyze data from particle collision experiments. The complex nature of particle physics data, with its many interrelated particles and properties, made Object Store's ability to handle complex object structures particularly valuable. Another example is Versant, which has been used in telecommunications for modeling network infrastructures. In this case, the inheritance capabilities of the object-oriented model were particularly useful for representing different types of network equipment and their relationships.
Those are great examples, Victor. It really helps to see how these databases are applied in the real world. Now, I'm curious about how object-oriented databases compare to relational databases in terms of performance. Are there situations where one might outperform the other?
That's an excellent question, Sheila. The performance comparison between object-oriented and relational databases can vary depending on the specific use case. Generally speaking, 1. Object-oriented databases often perform better when dealing with complex, hierarchical data structures. They can retrieve entire object graphs in a single operation, which can be more efficient than joining multiple tables in a relational database. 2. Relational databases typically have an edge in simple tabular data scenarios and when performing complex queries across large datasets. They benefit from decades of optimization techniques and robust indexing strategies. 3. Object-oriented databases can sometimes offer better performance in write-heavy scenarios, as they don't need to decompose objects into tables. 4. Relational databases often have an advantage in read-heavy scenarios, especially when the queries involve aggregations or operations across many records. It's worth noting that many modern database systems are hybrid solutions that attempt to combine the strengths of both models.
That's really helpful, Victor. It seems like the choice between object-oriented and relational databases really depends on the specific needs of the application. Now, before we wrap up, I think it's time to reveal the answer to our quiz question. Victor, would you like to do the honors?
Of course, Sheila. The quiz question was, in an object-oriented database, What feature allows a new class to be based on an existing class, inheriting its attributes and methods? And the answer is inheritance. This is a key feature of object-oriented systems that allows for the creation of hierarchical relationships between classes, promoting code reuse and logical organization of data and behavior.
Thank you, Victor. That wraps up our discussion on the object-oriented model. To summarize the main points: 1. Object-oriented databases represent data as objects, which encapsulate both data and behavior. 2. Key concepts include objects, classes, inheritance, encapsulation, and polymorphism. 3. They excel in handling complex hierarchical data structures, but may face challenges in areas like standardization and tool support. 4. Object-oriented databases find use in specialized fields like CAD, CAM, multimedia, and scientific applications. 5. The choice between object-oriented and relational databases depends on the specific needs of the application, with each having its own performance characteristics. Victor, any final thoughts before we sign off?
Just to add, Sheila, that while pure object-oriented databases aren't as widespread as relational databases, many of the concepts we discussed today have influenced modern database systems. We see object relational mapping in many applications, and some NoSQL databases incorporate object-oriented principles. Understanding these concepts is valuable for any database professional or developer.
Excellent point, Victor. And to our listeners, thank you for tuning in to another episode of Database Internals Crashcasts. If you enjoyed this episode, please visit crashcasts.com, join our Discord community, or support us on Patreon. Don't forget to subscribe and rate our podcast. Your support helps us continue creating content that demystifies the complex world of databases. Until next time, keep exploring the fascinating world of data.